Okay, in this video I'm going to show you how to do the axle peg. And like all the other pegs, I've found that the easiest way to build this part is with the revolve command. So we're going to build a sort of a quarter section profile and then revolve that. And this one doesn't, on the worksheet, does not show you a half section isometric view. So you kind of need to figure out the dimensions and what the section looks like that you're going to create in the profile. But essentially the overall height is 0.125, which is the height of the head of the bolt, plus 1 inch, which is, obviously 1.125, and 90 degrees. You can zoom out. And the diameter of the bolt is a quarter inch. It's a quarter 20 UNC. And again, we're creating half of this and we're going to revolve it, so we need a radius of 0.125 at 90 degrees. Click there. The height of the threaded portion, or at least the barrel of the quarter inch diameter portion, is 1 inch. Then the overhang here, you have to again do some more math. You'll see a note that the diameter of the head is 0.422, which means the radius would be 0.211. And we already know the radius of the shaft of the bolt is 0.125. So we can make the overhang 0.211 minus 0.125, which I believe is 0.086. Yes. Then if I zoom in here, you'll notice there's sort of a flat edge, which is I think it's a 32nd of an inch, 0.03125, 90 degrees. And I'm just going to move this dimensional constraint down here so you can kind of see what's going on. Okay. Now we need to do the arc, but notice there's a flat on the top of the bolt, which starts here and goes up 1/8 of an inch. It's 1/4 of an inch diameter, so it's 1/8 of an inch radius. Now we create the arc. We're going to use a 3-point arc for this, starting from the end of that arc, line, I should say, to the end of that line, and a radius of 0.236. 0.236. Oh, I messed that up. All right, well, we can fix that just by dimensioning this. Not sure why it's fully constrained now. I can turn on F8, show me the constraints here. Do not want that to be tangent there, so there's the problem there. In fact, we want this dimension to be 0.236. Now, we're fully constrained, but you'll notice this doesn't quite line up with that. I'm not going to worry too much about that because, again, this situation here, it's you don't need to worry about the curve is tangent to the line. Okay, if you wanted to, you could then make that that center point coincident with that line, but we don't really need to worry about that. So I'm just going to turn off the constraints. I'm going to do my revolve command, select the profile there, and I can select the axis either here or, of course, in the browser. There's my fully revolved part. Now I got 3 more features to add. First of all, I need to create that hex socket. So the way I do this is create a sketch on that flat part. We're going to make a hexagon on the top, right? And I don't really care what you call the what size you make that, because all we're going to do is then go and dimension between the flats and make that what we want it to be, which is it says right on the worksheet 5 30-seconds across flats. So I don't need my calculator. I just go 5 30-seconds, and there we are. Now I'm going to extrude that hex profile, a depth of 0.111, just so that we can get like a little hex wrench in there. to tighten it or loosen it. Okay, now I need threads on the bolt. So I go to the thread feature. I don't want it full length because you'll notice the threads don't go up all the way to the top. So I'm just going to change the length to, I think it's 0.75 inch threads. Sorry, 0.75 inch. That looks like what we want. And then the last feature we need to deal with is just the chamfer on the bottom edge right there. And that chamfer is 0.03 inches at an angle of 45 degrees. And that, I believe, is our finished axle peg.